Good evening, children. Good evening.
Good evening, ma'am.
Good evening, children. Yeah, I think we have to continue from here. Did we finish this one? This is over, I remember. Okay, let's continue from here. So if the points A and B are on the circle with center O 2, 3, find the value of x. So circle, center O given by the coordinates 2, 3. A lies on the circle, meaning A lies on the circumference of the circle, 4, 3. And B also lies on the circumference of the circle, x, 5. Okay. So circle with center O, coordinates of O, 2, 3. Then there are 2 points A and B on the circle meaning on the circumference of the circle. So A 4, 3, B x, 5. We need to find the value of x. So we need to get some condition. So when you join O to A and O to B, clearly OA and OB are the radii of the circle. So OA is equal to OB. OA is equal to OB. Now you cannot assume that, you cannot assume this figure, children. You cannot take this figure. See here like this. Like this you cannot take. Because it's not given that A and B are the end points of a diameter. It's not given. It's not given that the points A and B are the end points of a diameter. End points of a diameter. That's not given. So you cannot assume this. You cannot make the figure like this. A and B are on the circle. That's all. Anywhere on the circle. So you must assume this case where they are not the end points of the diameter. So that's a general thing. Okay. So you cannot take this figure. You cannot assume A and B to be the end points of a diameter. If that was the case, that will be given to you. That would have been given to you. So like this, you'll have to do. I'll draw again. Circle, center O, address is 2, 3. A is a point on the circle, 4, 3. You can take B here. B is another point on the circle, x, 5. Okay, so join O to A, radius. O to B, radius. OA is equal to OB. So that's the condition. Now you have an equality. It's easy to work now. So OA square is equal to OB square. So how do you write OA square? Don't write the square root symbol. X2 minus x1 the whole square. See here? OA. So subtract the x coordinates. 4 minus 2 the whole square. Subtract the y coordinates. 3 minus 3 the whole square. Then OB square. So use O and B. The coordinates of O and B. So see, subtract the x coordinates. X minus 2 or 2 minus x. Anything. Subtract the x coordinates. 2 minus x or x minus 2 the whole square. Subtract the y coordinates. 5 minus 3 the whole square. Any order. Subtract the y coordinates, any order. 5 minus 3 the whole square. Work this. You get x minus 2 the whole square is equal to 0. X minus 2 the whole square is equal to 0. That means x minus 2 is equal to 0 because x minus 2 the whole square is equal to 0 means x minus 2 is equal to square root of 0. X minus 2 is equal to square root of 0. X minus 2 is equal to square root of 0, which is nothing but 0. So x minus 2 is equal to 0, x is equal to 2. So the value of x is 2. The value of x is 2. So B is given by the address 2, 5. X, 5 is 2, 5. Write down, children. Please draw a figure. Write down quickly. Fast. Done, children?
1 minute.
Okay. Minus 2 is 2, 2 square is 4. 3 minus 3 is 0. 0 square is 0. So just ignore this. X minus 2 the whole square plus 5 minus 3 is 2. 2 square is 4. 4 on either side gets cancelled. So x minus 2 the whole square is 0. X is equal to 2. Yes, children? Over?
Yes, ma'am.
Right?
Completed.
All right, children. Yes. Find a point on the x-axis. Find a point on the x-axis. That means the y coordinate is 0. So how will the point on the x-axis look like? X comma 0. Find a point on the x-axis. Any point on the x-axis has its ordinate 0. That is, the y coordinate will be 0. So any point in the x-axis will be of the form whether on the right side or left side, will be of the form x comma 0. There'll be some x coordinate, y coordinate will be 0. Because you take, okay, let me do this. Okay, so what is this? 1 comma 0. This one, 2 comma 0. This one, 10 comma 0. Here, minus 1 comma 0. Here, minus 6 comma 0. So 0 is always there. That means y is always 0. There is some different x value. So x comma 0. Any point on the x-axis is of the form x comma 0. Find a point on the x-axis which is equidistant from A and B. So let that point on the x-axis be P. Okay, given by the address x comma 0. P is that point on the x-axis. Okay, 1 minute, 1 minute. Let's 1 minute. Where is minus 2 comma 5? Minus 2 comma 5 somewhere here. Okay, minus 2 comma 5. A minus 2 comma 5. And B 2 comma minus 3. 2 comma minus 3. This is minus 3. Okay, here. Okay, B 2 comma minus 3. Okay, so you'll have to find a point on the x-axis. Where is the x-axis? This is the x-axis. This is the x-axis. You'll have to find a point on the x-axis which is equidistant from A and B. So see, I don't know. I'm just taking this point. Maybe this one, P. Okay, so P is equidistant from A and B. That means the distance PA is equal to the distance PB, You will have to find a point on the x-axis which is equidistant from A and B. That means PA should be equal to PB. And what will be the address of P like? It will be of the form x comma 0 because it's on the x-axis. So its address will be something like x comma 0. So this is what it is. All right, so just work with that condition. You know the condition PA is equal to PB. That's all, distance formula. Start working. See, you don't know if it's going to be on the negative side or the positive side. I just took P there. Okay, so you can take it on the positive side also. We don't know. It's just a rough figure. We're just trying to understand the information given better with the help of this diagram. See, if you want to solve it in a different way, please do it in your method, but make sure you're getting this answer to -2. If you're not getting, please ask me. So I've just transposed this. Children, I just want to talk about this one. Please listen to me. Okay, so this one I've transposed, and then suddenly you can see the 8x here. I've used the identity. A plus b the whole square minus a minus b the whole square is equal to 4ab. Children, please listen to me. This one, in the next step, I've directly written 8x. How? I have used the identity. A plus b the whole square. A plus b the whole square minus a minus b the whole square. X plus 2 the whole square minus x minus 2 the whole square. A plus b the whole square minus a minus b the whole square is equal to 4ab. 4ab. 4 into a into b. 8x. 8x. You can even expand. You will get the same answer. So you save time by using the identity. Draw the rough diagram, children. Very useful. Even in the exam, you can draw that for better understanding. Done, children? Done, children?
Yes, ma'am.
Okay. Next one. Find a point on the y-axis. Okay. Find a point on the y-axis which is equidistant from a2, 3 and b minus 4, 1. So a2, 3, a2, 3, b minus 4, 1, minus 4, 1. You need to find a point on the y-axis. So maybe here, maybe here. Okay. So let that point on the y-axis be 0, 0, y, because we know that any point on the y-axis has its x coordinate 0. X coordinate is always 0. Not usually it's not x 0 for x-axis and y 0 for y-axis. It is x 0 for x-axis, but it is 0, y for y-axis. Because any point of the y-axis will be of the form 0, x coordinate 0. Y coordinate will be some y value, some different values for y. So now, so let this be P be the point on the y-axis. So it will be given by the address of the form 0, y, such that PB is equal to PA. PB is equal to PA, equidistant. So this is the condition. PA is equal to PB is a condition. Work that and you will be able to find the, the point on the y-axis. You can mention here the required point on the x-axis. The earlier sum, the required point on the x-axis. On the x-axis is minus 2, 0. Yes, children, work this. So PB is equal to PA or PA square is equal to PB square. The required point on the y-axis. Please write it and I'll just come back in a minute. Any clarifications, children?
No, ma'am.
Okay, so 2 minus 0, 2 minus 0 the whole square. Don't use the formula a minus b the whole square. 2 minus 0 is 2 and 2 square is 4. And here this is like a minus b the whole square. So a square minus 2ab plus b square. This is 0 plus 4 is 4. 4 square is 16. And this one y minus 1 the whole square. A square minus 2ab plus b square. Then y square gets cancelled on both the sides and you solve for y. Y is minus 1. So the required point on the y-axis is 0, minus 1. 0, y we assumed, right? Y is minus 1. So 0, minus 1 is the required point on the y-axis. Yeah. If Q is equidistant from P and R, find the values of X. Is all similar questions. if Q is equidistant from P and R. So Q is equidistant from P and R. That means QP is equal to QR. QP is equal to QR. So that's the condition. QP is equal to QR or QP square is equal to QR square. Work that and find the value of X. And then we'll have to find the distances QR and PR using the distance formula. QR, distance QR and distance PR. You can take this figure. So QP is equal to QR. Right, QP. QP is equal to QR or QP square is equal to QR square. QP is equal to QR. QP square is equal to QR square. So you know how to write QP square. QP. Subtract the X coordinates, subtract the Y coordinates, whole square. So let me just explain this, children. So on solving, you get X is equal to plus or minus 4. So X, so this R is given by two address. R is given by two address. R can be 4,6 or minus 4,6. So you're getting two values for X. X is equal to minus 4 or plus 4. So that means R can be 4,6 or minus 4,6. 4,6 or minus 4,6. So when you have to find the distance QR, you know, Q is only one thing, 0,1. But R is 4,6 or minus 4,6. So you'll have to find the distance, meaning you'll have to find two answers for QR. So when Q is 0,1 and R is 4,6, QR is this one. And when Q is the same thing, 0,1 and R is minus 4,6, QR is this length. It's the same, but you'll have to work both. And again, PR, you'll have to find the distance or the length PR. PR, P is only 1.5,3, 5,3. P is only 1.5,3. But R is 4,6 minus 4,6. So when R is 4,6, when R is minus 4,6. So PR, you should find PR. In one case, you get root 82. In the other case, you get 9 root 2. Am I clear, children?
Yes, ma'am.
Okay, please work. Do not blindly copy. Please do not blindly copy. Understand and then write, or understand as you are writing. So these steps, just don't copy, just don't write like this from here. You solve it and see if you're getting plus or minus 4. Don't copy from the slide. Finish, children? Finish writing?
1 minute, ma'am.
Okay. Yes, children, it's time. Is it over?
Yes, ma'am.
So I haven't shown the working here, but I hope you understand. So difference between the x coordinates. So 0 minus 4. What is 0 minus? See, children, one thing is when you're finding QR, you have to take the square root. Only when it's an equation like this, QP is equal to QR, you can say QP square is equal to QR square, and you'll work without the square root. Now, when you're finding the distance QR, it is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Don't forget the square root symbol. So QR, square root of, see when you subtract the x coordinates, what is it? 0 minus 4. So minus 4 whole square, 16. Directly I've written 16. Then subtract the y coordinates, 1 minus 6 minus 5 square, 25. How do you find QR? Subtract the x coordinates, 0 minus 4 whole square, 16. Subtract the y coordinates, whether 1 minus 6 or 6 minus 1, whatever. 6 minus 1, 5 square, 25. Here again, subtract the x coordinates, 0 minus 4, so 0 plus 4, 16, 4 square, 16. Then subtract the y coordinates, 1 and 6, so 5, 25, 25. So like that, like that. Subtract the x coordinates, 5, 4, 5 minus 4, 1, 1 square is 1. Subtract the y coordinates, 6 and minus 3. You'll have to subtract 6 and minus 3. So 6 minus 3, 6 plus 3, 9. 9 square, 81. Five minus 4 the whole square. Subtract the x coordinates. 5 minus 4. So 5 plus 4, 9. 9 square, 81. Then subtract the y coordinates. 6 minus 3. Or minus 3 minus 6. Subtract the y coordinates. Minus 9. Square it, 81. Now, whenever you have, 81 plus 81 like this, write it as 2 into 81 because 81 is a perfect square. 81 is a perfect square. So write it as 2 into 81. 2 times 81. So 81 comes out of the square root as 9. So 9 root 2 units. 9 root 2 units. Even if you add it, 81 plus 81, when you add, you will get 162. So you will get root of 162. Now, to express it as a mixed surd, you will have to. Are you all listening, children? Class, use the emoji. Raise your hand. Okay, so we have Ramanathan, Tarun Murali, Ananya, Harini Sneha, Nandini, Rajarajeshwari, Murali Krishna, Hitesh, Kanishka, Netra, Priyanka, and Sashmeen. Sashmeen, are you there?
Yes, ma'am.
All right, very good, children. All right. So I was telling you. Yeah. So I was telling you, even if you add root 81 plus 81, you get square root of 162. Okay, 162. Now you have to express it as a mixed surd. Mixed surd. So 162. 2 8s are 1s are. Then 3 and all that. Okay, so you can use 3 or you can use 9 also. We shouldn't use a non-prime number, but I'm just finishing it like that for you. So 9 ones. Okay, so you get square root of 2 into 9 into 9. So from 2 nines, 1 9 comes out 9 root 2. That's what you'll get finally. So what you can also do is when you have square root of a perfect square, 81 plus 81, perfect square, you can write this as 2 into 81. So you're not disturbing the perfect square. 81 plus 81, when you add, you're disturbing the perfect square. So when you don't add and you write it as 2 into 81, 2 into 81, you're not disturbing the perfect square. So 2 into 81, now 81 comes out of the square root as 9, root 2 units. So this way you can, save time. Otherwise you'll add and then you should take up 162 again and find the prime factors and all that. So you can save time. Doing this, you can save time. So when you have a perfect square, don't disturb it by adding. So 81 plus 81 is 2 into 81. So 81 comes out of the square root as 9 and 2 remains under the square root. So 9 root 2 units. It is important to write it as a mixed surd. Wherever possible, you should express it as a mixed surd. See now, square root of 41 cannot be expressed as a mixed surd. Square root of 41 is square root of 41. You cannot express it as a mixed surd. Then it is fine. Otherwise, you should express it as a mixed surd wherever possible. Okay, so find the values of x and y. Find the values of x and y if the distances of the point P from A and B are 4 units. Find the values of x and y if the distances of the point P from A and B. So the distance of P from A is 4 units and the distance of P from B is also 4 units. The distances of the point P from A and B. So P to A, P to B, the distance PA and PB, both equal to 4 units. So given this, you need to find the values of x and y. So see here, PA. So see distance of the point P from A and from B is 4 units. So PA is equal to 4 units. PB is also 4 units. PB is also 4 units. So let's work with PA is equal to 4. See, that's a condition. No, it's an equation. PA is equal to 4. That's an equation. Work that. So PA is equal to 4. That means PA square is equal to 16, squaring on both the sides. So how do you find PA square? Don't put the square root symbol. Subtract the x coordinates. X plus 3, the whole square. Because x minus 3. Subtracting the x coordinates, a whole square, plus y minus 0, the whole square, is equal to 16. So work this and you get this equation. You're not able to find the value of either x or y. You get an equation like this. Next, PB is equal to 4. So that means PB square is 16. PB square is 16. So PB, subtract the x coordinates. PB, subtract the x coordinates, x minus 3, the whole square, subtract the y coordinates. Okay, y minus 0 or 0 minus y, whatever, the whole square. And that gives you this equation. Now write the equations one below the other because you have x square x y square, x square x y square. Okay, you have x square x y square, x square x y square. So write the equations one below the other and solve them. Change the signs. Why do you have to change the signs? Because we have x square and x square, but you can't cancel. It will become 2x square. We have y square and y square, but y square plus y square is 2y square. How can you get rid of them? By changing the signs throughout. That is by subtracting the two equations. So see, this is the first equation. This is the second equation. Change the signs throughout in the second equation. So after changing the signs, x square minus x square cancels. Y square minus y square cancels. Now this minus becomes plus. So 12x is equal to 7 minus 7 is 0. Okay, 12x is equal to 0. That means x is equal to 0. X is equal to 0. Now we have to find the values of x and y. We found the value of x. So substitute x is equal to 0 in any one of the equations to find the value of y. And y is equal to plus or minus root 7. Please work, children. Done, children? Finish writing?
Ma'am, 1 minute. Ma'am.
Okay, okay.
Done, ma'am.
Yeah. All of you? Okay. Got it. Two vertices of an isosceles triangle are 2, 0 and 2, 5. Okay. Find the third vertex if the length of the equal sides is 3 units. Two vertices. A triangle has 3 vertices. So the address of 2 of its vertices is given to us. 2, 0 and 2, 5. We need to find the address of the third vertex. Find the third vertex if the length of the equal sides is 3 units. Now we don't know which two sides are equal. We don't know which two sides are equal. But it's given that the length of the equal sides is 3 units. The length of the equal sides is 3 units. But we don't know which two sides are equal. So see, we need to check one thing before we, actually answer. So see here. So this is the triangle. This is the triangle I've called PAB. I've called the triangle PAB. I've called the triangle PAB. PAB. Okay, so you know that A is 2, 0 and B is 2, 5. Now we do not know the address of the third vertex X, Y. Okay, the third vertex is P, so take it as X, Y. Now the equal sides are 3 units. Now which are the equal sides? PA, or the 3 sides are PA, AB and PB. Which 2 sides are equal? So now we can only find the distance of, or the, sorry, we can only find the length of the line segment AB. See, you cannot find the length of PA. You cannot find. How will you find PA? You don't know the address of P. You cannot find the length of PB because we do not know the address of P. So we cannot find PB. But you can find AB. You can find the length of the line segment AB. So use the distance formula and find AB. You get AB is 5 units. But what is given in the question? The equal sides are 3 units. That means AB is not one of the equal sides. That means PA is equal to PB. PA is equal to PB. See, you cannot just take, let PA be equal to AB. You cannot take that. You cannot just say, okay, fine, let PA be equal to AB. We can't do that. What I'm trying to say is, we cannot find the length of PA because P is X, Y. So we cannot find the length PA. You cannot find the length PB also. But you can definitely find the length of the line segment AB because you know the address of A and you know the address of B. So you can find AB. So you find AB first. You find the length of the line segment AB. Okay, you get 5 units. AB is 5. But what is given in the question? It's an isosceles triangle. So 2 sides are equal and the equal sides are 3 units each. But AB is 5. AB is 5. That means AB is not any one of the equal sides, which means clearly PA is equal to PB. PA is 3 units, PB is 3 units. PA is 3 units, PB is 3 units. You can call the third vertex C also. I've taken it as P. You can even take the C. Let C be X, Y. Find AB using the distance formula. AB is 5 units. But it's given that the equal size is 3 units. AB is 5. That means it is not one of the two equal sides. It's that unequal side, that third side. So that means these two sides are equal. 3 units. This is 3, and this is 5. Okay, so now we have all the conditions. Just work with the conditions. So what are they? First we have PA is equal to PA, PB both are equal to 3. So take one by one. PA is equal to 3. That means PA square is equal to 9. See, now we have the conditions. PA is equal to 3 units and PB is equal to 3 units. PA and PB. Now don't take AB is equal to 5 units. In AB, you know the coordinates of A and you also know the coordinates of B. So working AB is equal to 5, but we know the coordinates of A and B. So don't work AB is equal to 5. We found AB is 5. Work PA and PB. So PA is equal to 3. So PA square is equal to 9. Please work that. You get this equation. Then work PB square. That is PB is equal to 3. PB is equal to 3. So PB square is equal to 9. Please work that. And when you work this, you get the value of y. So what will you do next? You have to find x, no? So you will substitute y is equal to 5 by 2 in this equation 1. And when you do that, you get a quadratic equation in x. You're not able to find the value of x. You get a quadratic equation in x. And you're not able to solve this by splitting the middle term. You are not able to solve this by splitting the middle term. So you have to use the quadratic formula. How many of you have learned this chapter in school, quadratic equations? Lower your hands and raise your hands again if you've learned this. All of you lower your hands. Yeah, now raise your hands if you've learned this chapter in school. Quadratic equations. Kanishka, Ramnathan, Rajarajeshwari, Netra, Harini, Sneha, and Tarun. Okay, so I have to tell you about the quadratic formula. Okay, now the quadratic formula is used to find the roots of a quadratic equation. Quadratic formula is used to find the roots of or the solutions of a quadratic equation. Now, what we know or what we have studied so far is to solve a quadratic equation by splitting the middle term. We only know that. That's what we know till 9th standard. We only know how to solve a quadratic equation by splitting its middle term. Now, sometimes it's not possible to split the middle term. Okay, sometimes it's not possible. You cannot find, because you can find only, rational factors. That rational also, if it is like fractions, 3 by 5, 4 by 7, you cannot find them. So basically, you can split the middle term only using integers. We can split the middle term only using integers. So we can find if the two numbers are something like -10 and -7, you can find out. Or if the two numbers are like 16 and -3, you can find out. So integers you can find. If you can split the middle term using integers, you can find. Fractions also, it's difficult to find. So in order to solve the quadratic equation, if it is not possible by splitting the middle term, we use this quadratic formula. How does it work? This is the quadratic formula. X is equal to minus b plus or minus root of. So those who do not know can make a note of this formula. The quadratic formula. So what's the standard form of a quadratic equation? Ax square plus bx plus c is equal to 0 is the standard form of a quadratic equation in one variable x. Ax square plus bx plus c is equal to 0 is the standard form of a quadratic equation in one variable x. Okay, so now the solutions, that is the values of x. X is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. Okay, and what are a, b, and c? A is the coefficient of x squared, b is the coefficient of x, c is the constant. So now, for example, if you have 3x squared minus 11x plus 7, a is 3, b is minus 11, C is 7. Because you'll have to compare it with ax square plus bx plus c. So a is 3 plus b is minus 11 plus b is minus 11. That means b is equal to minus 11 plus b is equal to minus 11. That means b is equal to minus 11 and c is equal to 7. Make a note of this if you have not learned in school. X is equal to minus b plus or minus root of b square minus 4ac by 2a. Okay. All right. So that's what we use here. Okay. So the value of a when you compare, sorry. When you compare it with ax square plus bx plus c, the value of a is 4, the value of b is minus 16, the value of c is 5. All right, so x is equal to, yeah, and one more thing I should tell you is if the equation is like this, you know, say z square, 3z square minus 11z plus 7, then you must write z is equal to minus b plus or minus root of b square minus 4ac by 2a. See, the what you should reflect here is the variable in the equation. If the variable is z, you should say z is equal to. Here the variable is x. So we say x is equal to. In general, we say x is equal to. In general, we say x is equal to because you're trying to find the solutions or the roots of the equation where the variable is x. So x is equal to. If the equation is in z, then you must say z is equal to minus b plus or minus. If the variable is p, you must say p is equal to minus b plus or minus whatever is the variable used. So now when it is say 3p square minus 11p plus 7 is equal to 0, then you will be comparing it with the standard form ap square plus bp plus c is equal to 0. Change the variable. Instead of x square, you say p square. Instead of x, you say p. ap square. Instead of x square, say ap square plus bp. The variable is p plus c is equal to 0. Instead of x square and x, use p square and p. And you must say p is equal to minus b plus or minus root of and all that. Reflect the variable. Okay, so a is 4, b is minus 16, c is 5. So see here, x is the variable. X is equal to minus b, children. What is minus b? Minus 16. Minus b meaning negative, minus b minus 16. So plus 16. Minus b. B is minus 16. See here, minus. And what is b? This is b. Minus b. Minus b. So plus 16 it is. It's plus 16. It's plus 16. That's why I've written plus 16 there. Minus b plus or minus root of b square. What is b square? 256. Minus 4ac. 4 into a into c. 4 into 4, 16 into 5, 80. Minus 4ac by 2a. By 2a meaning 2 into 4, 8. So work this. You get 176. You should find the prime factors. 176. 176. So 288 times, 244 times, 222 times, 211 times. Okay, so it's square root of 11 into, it is 176 is equal to square root of 2 square into 2 square into 11. 2 square into 2 square into 11. So from 2 2's 1 2 comes out. From 2 2's 1 2 comes out and 11 remains under the square root. 11 remains under the square root. So 4 root 11. So 4 root 11. That's what you see here. 4 root 11. Okay. So root of 176. However, see this working can be different. Okay. I've written 16 into 11. See, like if you know the tables, 16 11s are 176. Why we write 16 11s are? Because 16 is a perfect square. So I wrote it as 16 into 11. You can find the prime factors like this, and you can write it as root of 2 square into 2 square into 11. So 16 11s are 176. 16 is a perfect square. So that comes out as 4. 4 root 11 by 8. Next, what should you do? Take out common. 4 is common in the numerator. So 4 4s are 16. You understand that by 8. Now 4 1s are 4 2s are. So 4 plus or minus root 11 by 2. That means the two values are 4 plus root 11 by 2 and 4 minus root 11 by 2. We get two values for x. 4 plus root 11 by 2, 4 minus root 11 by 2. So what are the coordinates of P? We have to find the coordinates of P. P is given by x comma y, but x has two values. X has two values, but there's only one value for y, 5 by 2. So P can be 4 plus root 11 by 2 comma 5 by 2. Or P can be 4 minus root 11 by 2 comma 5 by 2. Y is only one value, 5 by 2 in both. This is one value for x, this is the other value for x. So the coordinates of P can be either of the two, either this or this. It's very simple, children. The working is very simple. Yeah. Please write. Done, children?
One minute, ma'am.
Okay. Who can tell me the steps after this one? Here after this one. X square minus 4x plus 25 by 4 minus 5 is equal to 0. So how do you solve this further?
And 4x square minus 16x plus 25 minus 20.
Minus?
20.
Very good. By 4 is equal to 0, right?
Um,
Okay, then?
No, ma'am. No, it's equal to 0.
By 4?
No, ma'am, it will, when multiply with 0.
Okay, so that's the next step. Okay, okay, yeah. And then next step, 4x square minus 16x
Plus 25 minus 20 is equal to 0. Plus 5.
plus 5 is equal to, when you cross multiply, 0. Correct. Very good, Ram. Thank you. That's what this written. So after this step, I've written this equation straight away. 4x square plus 16x plus 5 is equal to 0. These are the steps. It's just about taking LCM and cross multiplying. Let me know, children, once done. Done, children?
One minute, ma'am.
Okay.
Done, ma'am.
All right. Children, do you have any questions anywhere here? Let me clarify. So it's an isosceles triangle. You need to find the coordinate of the third vertex. You know the address of two of its vertices. So you know A is 2, 0 and B is 2, 5. You need to find the address of the third vertex. We have taken it as P, X, Y. Now the equal sides 3 units. Since you know the coordinates of A and B, it is easy to find the length of the line segment AB or the side AB. Find out. It's 5 units. It's given that the equal sides are 3 units. Clearly, because A is 5, it's very clear that the equal sides must be P and PB. AB is 5. So that means the equal sides must be P and PB, 3 units. So they are the conditions. PA is equal to 3, PB is equal to 3. So work with PA is equal to 3 and PB is equal to 3. So that is PB square is 9, PA square is 9 on squaring both the sides. So this is your first equation. On solving here, when you work, you get the value of y. So what will you do? You have to find the values of x and y in order to find the coordinates of P. So once you find y, what will you do? You'll substitute in the first equation to find the value of x. You get a quadratic equation. So in order to find the two values of x, you use the quadratic formula, and using which you get two values for x. See, after this, children, see, 176 should be expressed as a mixed surd. 176 should be expressed as a mixed surd. So here, like this, 4 root 11. Whenever there is something common, bring out the common factor. So 4 is common, bring it out. So you get 4 plus or minus root 11 by 8. Cancel. 4 ones are 4 twos are. So 4 plus or minus root 11 by 2. So 4 plus root 11 by 2 is the x coordinate, followed by the y coordinate 5 by 2. Or 4 minus root 11 by 2 x coordinate, followed by the y coordinate 5 by 2. So P can take any one of these two addresses. Think the line. Yes. Rajeshwari, or who's that? Children, I just want to take up something else here. Yeah, let's do this one. The food. Okay, sort of. All right. Now look at this, children. Check if the following points are collinear or form a triangle. So we understood in the introductory class that when we have 3 points in a plane, there are only 2 cases. When we have 3 points in a plane, there are only 2 cases. Either the 3 points are collinear. If they are not collinear, they must form a triangle, or they will form a triangle. These are the only 2 things that are possible. Either the 3 points are collinear. If they are not collinear, they will form a triangle. If the 3 points are collinear, then this plus this should be equal to this. That is, if you call the points P, Q, and R, then PQ plus QR will be and should be equal to PR. PQ plus QR is equal to PR if the points are collinear. If the points are not collinear, then you know this will not be true. PQ plus QR will not be equal to Q. PQ plus QR will not be equal to PR. So PQ plus QR will be greater than PR. Because you know when the 3 points form a triangle, the sum of any 2 sides will be greater than the third side. Okay. Check if the following points are collinear or form a triangle. Now do it, children. Find out AB, BC, and AC. Work AB, work BC, work AC. Let me see who can give me the answer first for AB. Yeah, what is the length of the side? I'm sorry, length seg. Oh, sorry. What is the length of the line segment AB? Be the first to answer. AB children. Oh, sorry. Any problem? Why? AB is equal to square root of difference between the x coordinates. So -4 plus 2 by 5, the whole square, plus difference between the y coordinates, 3 minus 6 or 6 minus 3, the whole square. Okay, so this is going to be square root of LCM 5. So -20 plus 2. So -18. -20 plus 2. -18. The whole square plus 3 square, which is 9. So that is a root of 18. 18s are how much, children? What is 18? 18s are 324, right? 324 by 25. -18 by 5 into -18 by 5. Into -18 by 5. So minus into minus plus. 324 by 25. 18 18s are 324. 5 5s are 25. Plus 9. Again LCM. 25 is the LCM. So 324 plus what is this? 225. 225. So now the sum of the numerator 9 and 4 5 549 by 25. Am I right, children? Are you all getting this?
Yes.
Yeah. Then write 549 as a mixed, mixed cell. Now 25 will come out as 5. 25 will come out as 5. So you can write it as root of 549 by 5 by 5. Now root 549, please express it as a mixed cell. That's important. Otherwise, it's difficult to comment. 2. So similarly, find BC and AC.
BC root 244 by 25.
Yes, Ram?
BC root 244 by 25.
No, you cannot go to BC. Now tell me AB. Express root 549 as a mixed surd and tell me the value of AB. Yeah. Yeah.
3 root 61 by 5.
Okay, Ananya. Louder, Ananya.
3 root 61 by 5.
Very good. So this is nothing but 3 by 5 root 61, correct? 3 by 5 root 61.
Yes, ma'am.
Yeah, 3 by 5 root 61 units. Looks correct. Very good. Yes, please proceed. Good, Ananya. So find BC class, find BC. So this is right, 3 by 5 root 61. Root of 549 by 25. AB is equal to root of 549 by 25. Was it 549, children? Was it 549?
Yes.
Okay. So this is nothing but square root of 549 by 5. So now 549. 549, 3, 3 ones are, 3 8s are 24, 3 3s are. Again by 3, 3 6 are, 1s are. Now this 61 is a prime number. 61 is a prime number. You cannot divide it further. So this is nothing but a root of 3 into 3 into 61 by 5. So from 2 3s, 1 3 comes out of the square root. So 3 root 61 by 5, which can also be written as 3 by 5 root 61 units. 3 by 5 root 61 units. In the same way, find BC and AC.
Ma'am. Ma'am. Ma'am, can you hear me?
Yeah, children, just a minute. I'll just get back. Just a minute.
Ma'am.
Yes, children, I'm sorry, I got a phone call I had to attend. I'm sorry. Yes, children, please tell me now.
I got BC as 2 by 5 root 61 and AC as root 61.
Okay. Now, is the sum of any two line segments equal to the third one?
Huh?
Is the sum of any two line segments equal to the third one?
AB plus BC will be equal to AC.
Yeah, AB plus BC will be equal to AC. So what will you conclude? If the sum of any two segments is equal to the third one, that means
The points are collinear.
the points are collinear. Very good. Good, Ananya. Yes, children, you can see it here. So yeah, you can see here 3 by 5 root 61. And here it is 2 by 5 root 61. And this is root 61. So when you find AB plus BC, 3 by 5 root 61 plus 2 by 5 root 61. So root 61 is common. See, I've taken root 61 common here. So you will get 3 by 5 plus 2 by 5 inside the bracket. 3 by 5 plus 2 by 5 in the bracket. 3 by 5 plus 2 by 5 root 61. Root 61 is common. Root 61 is common. So 3 by 5 plus 2 by 5. So that is 5 by 5, which is 1. 1 meaning 1 root 61 or 61 units. So AB plus BC is 61 units and AC is 61 units. AC is 61 units. So clearly AB plus BC is equal to AC. So that means A, B, C are collinear. A, B and C are collinear points. So you can write it like this after this one, you know, as I wrote earlier, root of 549 by 5. So this is nothing but root of, see, when you know the tables, you can write 6190. Otherwise, you can, you know, what did I do earlier? 3 into 3 into 61 by 5. So that's nothing but 3 by 5 root 61. Same thing here for 244. When you find the factors, you know, the prime factors, 3, 8, oh, it's not divisible by 3. So 2. So 244, 2, 2, 1, 2, 2, 2, 61. See here, 2 root 61. So it's very important to express as a mixed assert, children. You cannot have it like this. You cannot leave it as root of 549 by 25. 25 will come out as 5 and root 549. Root 549 should be, you should find the prime factors and express that as a mixed assert. Is that fine, children? So you see that AB plus BC is equal to AC. So the 3 points are collinear. Let me just show you the steps again. Oh yeah, see here I've shown for AB. AB is equal to BC is equal to AC was simple. 244, 549. 5. Okay, so what you do next, children? See, next you can write root of 549 by 25. Okay, so 25 comes out of the square root as 5. That's the next step. That is equal to 549. When you find the prime factors, we got what? 2 3s and 161. We got like this. Okay, so this is square root of 3 into 3 into 61 by 5. So from 2 3s, 1 3 comes out. Root 61 by 5, which is nothing but 3 by 5 root 61 units. Then for BC, this is nothing but root of 244 by 5. That is root of 2 into 2 into 61 by 5. That is equal to 1, 2 comes out. So 2 root 61 by 5, which is nothing but 2 by 5 root 61 units. So you can show it like this. Yeah, take a screenshot, children. If you have not finished or if you have to change your steps. Please take a screenshot, work it like this. Yeah. So AB plus BC is equal to AC. If this condition happens, then the points A, B, and C are collinear. All right, children. Take a screenshot if you have not finished. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you, children. Thank you. Thank you.